Hello, and welcome to Module 5, Lesson 2. So today we're going to talk about erosion and deposition from a variety of agents. All right, so the focus question for the notes, so something to think about while we're doing the notes today, is how does erosion done by ice differ from erosion done by water? So we'll look at both. So glaciers versus running water is usually what we're talking about. So rivers versus glaciers. All right, so gravity. This is kind of an interesting picture. So gravity is the force of attraction between objects because of their mass. So this is a picture of the Earth and the Moon. And so the Earth is kind of this space-time continuum it's sitting on. And so because of the weight and the mass of the Earth, it's weighting down. Think of this like a blanket. So this is gravity. So the Earth is sitting on this blanket and it is heavier than the moon. So it's sinking into the blanket of gravity, of space-time continuum, more than the moon is. And so because of that, think of the moon as a marble kind of going around. And so that marble is pulled towards that depression. And so the marble, the moon, orbits the Earth because of that. And so that's basically what gravity is. And we'll talk a lot about that in the astronomy unit. All right, so different variety or different things of erosion. So erosion is obviously when we have rock being moved from one place to the other. So we talked a little bit about that last unit. But erosion can occur from a variety of reasons. So glaciers, wind, ocean currents, waves, gravity. That's by running water. Glaciers are the only thing in there that would be frozen, but everything else would be abrasion and just because of moving water. All right, so I'll move my little picture. But deposition, this is a big deposition. So this is done by gravity, and this is a big landslide. And you can see this went down into these houses. I think this one was quite a few years ago, but it did end up killing a couple people. But that happens sometimes. It's unfortunate. But you can see this big kind of landslide occurred, and this was due to unstable ground. So the grass and brush and whatever this is wasn't holding this, and it looks very sandy, so it doesn't hold it very well. And then there could have been a lot of rainfall, potentially an earthquake or something occurred where it caused the land to loosen and slip and deposit. So that's one way that deposition can occur by gravity. Another way deposition can occur is by water. So this could be because of water flow, like a river, or maybe excess rain or something like that. But we can see here we've got some erosion occurring. We've got this little stream here carrying sediment. It looks like it's full of sediment. It's very brown colored. And then if we look at this stream here, it could be the same thing here. So we've got erosion occurring on the outside, and then on the inside, we've got deposition. So about a week ago or so, I mentioned something about gold panning. So if you're into gold panning, then or finding gold, then where you're going to look is where it's being deposited. So you're not going to look out here where it's being eroded, but you would look where it's being deposited. And the reason it's deposited here is because the stream flow has less velocity, so less speed. And so out here, though, it's got more speed. So it's coming around the corner and it's eating away at this bank because of the force. And then here it's depositing because the water is moving slower, and so it can't carry as much sediment, so it starts to deposit. And that's where we would find our gold deposits or just deposits in general. So here, if we're looking at this one, erosion would occur here and erosion would occur here. So as the water is moving through either direction, then this is where it's going to be eating away. This is where deposition occurs. So as it comes around the bend, it's going faster here than it would be here. So we would expect to see this river meander more. So right here, it's got a little meander, which means just curve. And then the more it runs, the more it tends to meander. So think of the Sacramento River. The Sacramento River meanders quite a bit. Once it gets down into the valley, it kind of weaves back and forth. If you go down I-5, you cross it numerous times. And up here, though, it doesn't as much. It weaves a little bit, but not as much. And so that tends to be, as the river gets bigger and wider, it tends to do that a lot more. The Mississippi River is a great example of that. All right, so here's a really good example. And we even get these weird little formations. So these little lakes, these are formed because the water used to maybe go that direction, and then it's been cut off because of deposition. So these big, huge meanders in this river. So we've got deposition occurring here and here. We've got erosion occurring out here and out here. Same thing over here. We've got erosion. So the meanders are just going to get bigger and bigger. You've got erosion here, and you've also got erosion here. So what do you suppose is going to happen if we are constantly eroding here and here? Well, it's probably going to join at some point. So at some point, the river is going to erode enough where it's going to join this side. And then the river is going to want to flow in the shortest possible way. And so if the water comes this direction and this is open, the water is going to flow through here, and it's going to create a new meander, and deposition is going to be occurring. And what's going to happen is this is going to be cut off, and this will be what's called an oxbow lake. So that would be this oxbow shape, and then the river would go this direction, and then it'd be this curvature lake, and that's an oxbow lake. All right, so water can also cause erosion in land. And so it occurs like during heavy rainfall, for example. So on this hillside, we've got what's called rill erosion. So water running down, eroding, there's not much vegetation here, so it's just pulling away at the soil. And it forms these little like ridges and rills. They're tiny little, think of it as tiny little gullies. For example, and then here's a bigger one. So you can see a gully has now formed. This is not the best for this guy's land. Maybe he's a farmer. I'm not sure what this is, but that's a gully. So rill is just small. You can think of rills as just smaller gullies. All right, and then when a river finally has eroded off the land, out of the rivers, out of the mountains, it eventually deposits into a larger body of water. And so think of this as this might be the ocean here, and this is a river coming in. And so you can see all this deposition, all this stuff was being carried by the river, and that's the delta of the river. And so as it hits a larger body, it slows down. So it's not moving as fast, and when it doesn't move as fast, it can't carry as much sediment. So that sediment starts to deposit and starts to settle out, and you've got this big delta forming. So all rivers, when they dump into a larger body, they form a delta, and this is the mouth of the river. So all rivers have a mouth, and that's where it dumps out into something else. So the Sacramento, for example, dumps out into the bay, and so the mouth of the river would be there. Mississippi River dumps out into the Gulf of Mexico, so that would be where the mouth of the Mississippi River is found. All right, and then we've got oceans. So wave action occurs, and you guys maybe thinking about the last time you were at the ocean, if you've been to the ocean. The ocean is constantly changing. The erosion on the shore. Maybe you've gone to Agate Beach, and every time you go to Agate Beach, the staircase going down to the beach is completely different. There's erosion occurring constantly. So wave action is pretty strong. You've got waves kind of crashing into the shore here. And this is a platform that's cut by wave action. So we've got tides going in and out. The water gets higher, it gets lower, and that creates this kind of shelf, which is called a wave cut platform. And then you've got cliffs like we see on especially Northern California. And then we've got this recession area. So the cliff used to be right here, and it's receding because of this wave cutting. The Northern California coastline is a great example. So up by Eureka, Trinidad, all along the Northern California coast, you've got this good example of these cliffs and platforms and lots of erosion. All right, and so it does become a huge issue when you've got people building on that. So if we go back to the previous slide, think about houses. So this is great view, right? You're up here, you've got a really nice view of the ocean. Well, what happens is this is constantly changing. So if this is constantly changing, I would not want my house up there. And that's because eventually it's going to crumble, and this cliff is going to be gone. And so is your house. So that's a huge downfall to living on the coast, is that houses are constantly falling into the ocean. So wherever you've got houses built on the coast, if they're not built far enough back, they end up crumbling down into the ocean. So pretty devastating. But that is, being impacted by human development. We're not only, developing on the coast, but we're also doing things to land that affects the erosion. So walking along the beach, walking in the sand, thinking it's no big deal going to the ocean. Well, what you do is plants hold sand, soil, their roots hold it. And so if you're walking in an area and you're constantly trampling down or we're developing, building stuff, then we're taking those plants out. And if we take those plants out, it creates further erosion. And so humans are hugely impactful on sediment and soil, and we really kind of escalate erosion. All right, so this video is going to kind of talk a little bit about platforms. I'm not platforms, but different features that we see along the coast. And so think about Eureka, think about Northern California coast, and we get all of these different features forming because of erosion.
The continual battle between land and sea is apparent here, along the northwest coast of America, where erosion is the predominant force. Millions of years ago, this coastline would have looked very different. Even though the land is tough basalt, the relentless attack of the sea has eroded it in spectacular ways. Cliffs are formed when weathering weakens the top of the land, and destructive waves attack the bottom of the rock face. Weak points in the rock are affected most, and eventually form a hollow, called a wave-cut notch. The overhanging rock collapses, and the rubble is carried out to sea, forming a wave-cut platform. The whole process continues, causing the cliff to slowly, but continually, retreat. But erosion also produces more unusual features. Hollow caves can be carved out by the water and eventually break through, forming an arch. The continual erosion keeps widening the arch until it can no longer support the land on top. The arch collapses and leaves a headland on one side and a tough outcrop of rock on the other, called a stack. Whilst erosion constantly attacks our coastlines, deposition builds characteristic landforms. When constructive waves wash onto the shore, they dump material carried in the water, like sand, pebbles, and rocks. This builds up beaches. Whether a beach is soft and sandy, or hard and pebbly, depends on both the wave energy and the local geology. A narrow, extended stretch of beach that projects out to sea is called a spit. These are formed by deposition as well, but wind conditions also have a part to play. Where the prevailing wind blows at an angle to the coast, it causes longshore drift. Material is moved along the coast at an angle. Over time, the wind and waves affect the end of the spit, causing it to curve to create a hook end. This creates a sheltered area protected from incoming waves. Silt is deposited, and mudflats or salt marshes can form. Erosion and deposition have created the world's beautiful and dynamic coastline, and continue to affect these ever-changing landscapes.
All right, so we can see quite a bit of erosion occurring because of oceans. And so you can see that, if, like I said, if you've ever been to the coast before, especially if you've gone a couple times, it is so different from even day to day. It's so different, but it erodes and is much different from year to year as well. So glaciers, they are actually a big erosional feature. So it's kind of weird to think of ice maybe sliding across the land and causing erosion. But it does, especially in the mountains. So if we look at this picture, we've got all these different features formed from glaciers. So we've got horns, which are just the peaks. Think of like the Matterhorn, for example, at Disneyland. So that is a horn that is formed from glaciers. And so that's why it's called the Matterhorn. And then we've got these cirques. So these are these circular kind of bowl-shaped areas. If you've ever been up to any of the lakes in the Trinities, the Shasta Trinity National Forest, any of those lakes up there, those are all cirque lakes. And so in the winter, they're frozen over by glaciers. And then in the summer, they are lakes. And they're cirques because this ice basically comes down and it's constantly eroding away on the land, and it causes this kind of bowl shape from these horns and a arête. So this is an arête, which is kind of like a ridge, and there's the Trinity Alps are great examples of these. If you've ever been out there, there is just an abundance of this stuff out there. And then you've got a glacier. So here the glacier is coming down, and in the wintertime, the glacier will come all the way down. In the summertime, the glacier will do what we call a retreat. So the glacier doesn't move uphill, but what happens is as it gets warmer, the snow melts. And so it looks like it's retreating back up the hill, but in a sense, it's just melting at the bottom. And then the glaciers come down and they form this U-shaped valley. So that's very, very typical of a glacial valley, whereas rivers will form V-shaped valleys. So they'll form kind of this V shape, whereas glaciers form this U-shaped valley. And so here we can see some evidence of glaciers. So here the glacier is coming down. This is the glacier here. And so it came all the way down into this area. But what happened is it's retreating now because it's warmer. And so as it retreats, it dumps all this material. This is called a moraine. And it dumps all this material at the end. That's all the material that was scraping along the ground and carrying. And then as it retreats, it forms these lakes, which are called kettle lakes. And then we've got these weird shapes called drumlins. They're kind of like these teardrop-shaped land formations, and they're perpendicular to the glacier. So notice how the end moraine is horizontal. Drumlins are always perpendicular. And then you've got another end moraine here. So this would be like maybe a different season. Maybe this was 20 years ago when the glacier used to come down this far. And now because of global warming, it only comes down this far in the wintertime. So there's a variety of things here. And then we've got runoff. So it's melting, of course, and that's coming down as little rivers and streams. And so we can see this in the Midwest. If you go out to the Midwest, glaciers in the last ice age came all the way down to kind of the middle of the Midwest. And we can see exactly where they came down and how far based on this here. So we can see end moraines, we can see drumlins, we can see, for example, in Minnesota, it's known as the land of 1,000 lakes. And the reason for that is because it was completely covered with glaciers. And as the glaciers retreated, they left behind those little lakes. The Great Lakes are formed by glaciers. So the reason we have the Great Lakes is because they're depression areas that filled with glacial water. And now they're the Great Lakes. And so if we look at this rock here, you can see this scraping is caused by a glacier. So that's very typical of glacial erosion. So the glacier came across, and the glacier is carrying all this rock. So as the glacier scrapes across the land, it's gouging it and creating all these lines. And so that would be definitely formed by a glacier. This is a great example of a glacial valley. So all of this was formed by glaciers moving down during the last ice age. And this is Yosemite Valley. If you've never been here, there's Half Dome in the background. This is El Capitan, really popular Solo, the movie, the guy that climbed without any ropes or anything. That's what he climbed, is this here. But this is a U-shaped valley. So you can see very, very U-shaped throughout here. So that's a glacial valley. It's often forming hanging waterfalls. So if you've been to Yosemite, there are lots of waterfalls. And so they just plummet right off the cliffs here. And that's because of glaciers. So it formed this U-shaped valley, and we've got these rivers that have nowhere to go. And so they basically just tumble off the sides. So U-shaped valley. If this were a river flowing down here that carved all this, like the Grand Canyon, for example, it would be more of a V-shaped valley. But we see a U-shaped valley here. All right, and then wind causes lots of erosion. We looked a little bit at this before, but wind creates lots of different shapes. So we can see here some shapes in, this is probably Utah, has a lot of shapes like this in the land. And so this is sandstone, and the wind blowing across creates kind of this sandpaper and takes that sand and blows it and scrapes it across the sandstone and forms these different ridges. And what happens here, the reason you've got this like platform rock here, is because this rock is probably a different type of rock. So it's a different mineral in here, something that's harder than the rock that it's sitting on. And so you get these really cool formations like arches and platforms and all kinds of things because of wind. All right, and then this is also wind, but this is a wind break. So what happened here is if you just have land that is completely open and flat, in the wintertime, especially when you have nothing planted, what's going to happen is it's really windy. Wind can pick up, anywhere. And so the wind blows across here. And if there's no wind breaks, nothing to kind of break the wind, then it causes the erosion of the soil. So basically all the soil blows away. And then you don't have fertile farmland. And this farmland takes thousands of years to form. So this really nice soil takes thousands of years. And you can have a foot of topsoil lost, and that takes maybe 1,000 years to form. You could have a foot of topsoil lost in one season if you're not careful. And that takes, like I said, thousands of years to form. So that would not be good, especially since we need to feed people. So they create these windbreaks, and these windbreaks are just barriers. You've probably seen them as you drive down to Sacramento. You see like rows of trees kind of blocking or separating fields. And the reason for that is because they stop the erosion. So if the wind whips through here and all this is fallow, meaning there's nothing on it, then that if the soil does end up blowing, it blows and kind of stops along these wind barriers. And so they could take their tractor and kind of spread it back out if that happens. If they don't have those, then it blows into the air and out. And a great example of that is the Dust Bowl. And so that was poor farming practices mixed with severe drought, and they didn't have wind breaks. We didn't really understand a lot of that. And so it just created this huge problem.
We watched a dust storm come up like the Red Sea closing in on the Israel children. And I'm telling you, it got so black when that thing hit, we all run into the house. And a lot of people in the crowd that was religious minded, and they was up pretty well on the scriptures, and they said, well, boys, girls, friends, and relatives, this is the end. This is the end of the world.
This was a 10-year apocalypse that I don't think we can fully appreciate because we tend to pigeonhole stuff in American history and say, this is the grapes of wrath, boom, done. It's much more complicated than that. And the story of the human beings that survived this 10-year apocalypse is one of the most moving and one of the most dramatic stories I think we've ever come across. This project was born 2 decades ago. Dayton Duncan wrote a marvelous book called Miles from Nowhere, in which he visited many of the least populated counties, some of which are in no man's land, what became the Dust Bowl.
I met a number of people who told me these incredible stories about the dust being so bad that they would huddle in the shacks of their homes with claws over their face. And they were just incredible stories, both in terms of an environmental story, of human folly, but also of human courage and suffering and perseverance. So that got me interested in it at first, and then a lot of other things, intervened, other films, other stories. But it was always on the list of films that I was hoping that Ken and I would get around to doing.
It's the testimony of more than 24 human beings who lived through it, who survived the greatest man-made catastrophe, environmental catastrophe in American history, superimposed over the greatest economic cataclysm in world history, the Great Depression.
First of all, this was a 10-year drought, so that was a longer than normal drought. It just didn't let up. It just started and kept on going. It was a harmonic convergence of bad things, of a badder than usual drought, hotter than usual temperatures, and more soil exposed for the first time than ever before in history, due to both bad farming practices and human nature, thinking that they could make a quick buck. And all those things combine to make it just hell on earth.
All the birds, everything was flying south. We could see this thing rolling in. And my brother told me he thought the end of the world was coming. Well, of course, that scared me half to death, and I wasn't so sure about it.
We've been working on this project now for several years. I still can't fully comprehend what it must have been like to be in one of these black blizzards. Towering mountain ranges coming at you more than a mile high, sometimes 200 miles wide, that could blot out the sun and make it inky black during the day, where you couldn't even see 3 or 4 feet in front of you, that there was not a safe place from the dust.
If it was one that was blowing more of a sand blow, as they were sometimes called, that would be closer to the ground, and these grains of sand, people would say, could strip the paint off of your car. Obviously, if you were out there and exposed to it, it could hurt like hell when it hit you. If you went inside, newspapers sold special gum tape to put around the edges of your windows and under your doors and other things to try to keep this dust from getting in. Nothing worked entirely.
Before these storms happen, there's an incredible phenomenon that builds up a lot of energy, a kind of static charge.
I can remember feeling it in my hair. It's just kind of like your head tingles or something, your hair just kind of wiry.
If you reach out to touch a car, the electricity will jump out about 6 inches to meet you and knock you right flat on your butt.
It would short out the electrical system, the radio, other functions of the car, and so people took to dragging chains behind them just to ground automobiles.
It was tough times. It was really, really tough times. We didn't know what the devil was going to happen next.
It seems to me as if we were all just suddenly picked up and deposited back into the Old Testament Egypt with the Israelite people, as Woody Guthrie would say, that there were plagues of jackrabbits because nature had become so unbalanced. That there were plagues of locusts that afflicted these people. It wasn't just the dust storms, as if that wasn't enough for 10 years, that you had the poverty of the Depression, that people are trying to get out, people are starving. This has got to be a cataclysm that we don't just see as an environmental parable, which it is, but as a human story, a human drama, in some ways unequaled in this tiny, forgotten part of this glorious continent.
So pretty extreme, but it definitely could happen again if we aren't careful. All right, so if we look at erosion, erosion occurring by the last thing, which would be living things. So humans, you can see here, taking the land and farming. And so if we're not careful here, gully erosion, rill erosion could occur. Anytime you don't have plants holding the soil, it causes erosion. And so that's why, like after the car fire, for example, they put down straw on the ground, and that was to prevent erosion. Or hay, they had the little rolls of straw, and you can put those down so that you minimize erosion until the plants come back. So animals can cause erosion by drilling into the land. So you've got this little worm, and generally animals are good, especially worms. They're really good for the soil because they aerate it and they allow plants to be able to thrive. But they do cause some erosion by moving dirt throughout. Same thing with this little ground squirrel. So they're digging around, or prairie dog, digging around, forming holes, and they're causing erosion to occur as well. So those are a huge variety of things that are causing erosion. Thanks for watching.